So let's start. Can you see the screen?
Yes.
Okay. So we are going to I consider chapter 8 is on progress by last week. Uh, Maybe we need some additional picture and code must be tested. And now you can use cursor. So you just copy paste the code as cursor to improve the code, make it more robust, fix the bugs. So the good thing with Cursor now is you have agent integrated with IDE, right? Here at the back. Okay. So you just copy the code, make a new Rust project, and then copy the code from the book, and then asking question on the right side, and then talk to the AI. You can use Cloud Sonnet and fix the code in Cursor. Other than Cursor, you can also use the same method. You can also use this one is Windsurf IDE. Okay. I prefer Cursor, but many other people maybe they like to use Windsurf. The same functionality. You can connect to many AI. In Cursor, you can check uh, many models you can use. The best is actually Cloud for me, but many people say Gemini 2.5 Pro Max is also promising. If you have your API key, you can put here, but uh, Cursor give you some free token that I think is enough for students. Yeah. Okay, so let's continue to the book. So I hope you can finish this and let's move to chapter 9 for today. So I'm done the curation. You need to make the code more robust and comprehensive. So don't just take the code here, but make it more robust and comprehensive inside the using the AI. Yeah? And also proofread the mathematics and text. If you think the mathematics and text need to be improved, then improve. Okay. So in this chapter, we are talking about gene expression. So gene expression is about how the genes transcribe to RNA and translate into protein. Okay. So how it will express the itself. So it's very important topic in bioinformatics because it's also heavy in computation. The key framework usually based on the central dogma from DNA to RNA to protein, right? So in quantitative term, transcription involves generation of messenger RNA from DNA template, and these messenger RNA molecules can be measured by sequencing method to infer the activity level of the gene. Okay, so to analyze the counts, usually we use statistic, use Poisson and negative binomial distribution. So this is the Poisson distribution. If you find this latex is not complete, you can, this one you can fix, yeah? Like this should be latex. So let let me fix. For latex, just make it like this. Yeah. Okay. So sometimes this Poisson have some issue regarding over dispersion. So usually we have to count the dispersion parameter C. Okay. So there's some modification here, and then sampling variance in RNA sequence experiments. Take the data from the from the data bank and then process the algorithm uh, to do the gene expression. Okay. So in this sample code, the first sample code is just a simple pipeline parsing the transcript to count file, normalizing data using scaling and printing summary and normalized counts. So it use traits like here, yeah, but it should use like this crate, but this code don't have that crate. So let's say I can say to cloud it, yeah. Uh, Let me check. And then you can say utilize that traits so it can modify the code here. Okay. Let me create new project. Okay, let's say your initial code is like this. We just pass here, okay? And then you can say to AI on the right side, uh, complete the cargo.toml file, okay? And improve the, oh, sorry, re-implement the code using what library you want to use before this one, right? Make it more robust and comprehensive, okay? Revise the toml file and compile the code. If you find error and warnings, just fix them all, okay? Okay, and then the AI will work for you. It will directly impact the code on the left side. Let's see, this toml is blank, okay? And also this code is just like this. And when it start work, it will generate new code, okay? And it generate new toml, including the crate that I asked to use, okay? And then look on this. It's still generating. If you have the free version, usually it's quite slow like this when it works. But if you have the paid version by usage, it works really fast. Okay, it can create the code in second as long as you know what you want to modify in the code. Okay, still building the library. Let's wait. Okay, so this code is just open a transcript count file, read it, do looping, count, normalize count, and then print the result. It's very simple code, yeah. But let's see how it can improve. So it improved like this, and then ask you, do you want to accept the change or not? Let's say I accept the change, and this is the change. Okay. And remember, I want to compile without error, without any warning and error. Okay. Okay. So it's still working. Now it's 400 more. It's more robust, right? And let's see if it can compile well or not. Just accept if he wants to do some changes. So this one is like slow because it's not the paid version. But if you have the paid version, it's really, really fast. Yeah. Okay. So we don't have to wait because it will work until it compile. So I just want to show you because this is not something too heavy to do. Yeah. Let AI working for you. So make the code more robust and more comprehensive, and then also you can fix this, give the next flow color for the for to the AI so it can be aligned your code. Okay. So data acquisition and transcript quantification is very important aspect of gene expression. So from the data, you read the data, okay, and then put in some data structure, okay. The central tools, of course, is sequence alignment. So alignment involves matching the short read derived from RNA sequence experiment to the reference genome or transcriptome, okay. Usually we use BWT is a method that very common method. Also, for short read aligner, there is many library previously like BOTI. It's a very famous library for that. Okay, you can check this part, check the mathematics, and then once you found the code, make it more robust and comprehensive, like what I did here. Okay, so you just even the code is long, it's okay because we want a robust code in this chapter and following chapters. And also maybe starting from chapter, uh, maybe you can revise this chapter 8, okay, uh, to make it more robust. Later we can fix more robust codes using the AI coder, yeah. But let's start in chapter 9 to pilot the better code for the book. Okay, because the book will be released as a web book. Don't worry about the length of the code because people can just copy paste from the web, not like printing the book on the paper. Okay. Okay. So let's get back. So I hope you can improve the code of section 9.1, 9.2, and 9.3 is focused more on normalization, how we normalize the count, the data from the gene expression analysis, and what kind of algorithm that is being used. Usually it some algorithm here, CPM, RPKM, TPM is a very common term in bioinformatics. So you just check the mathematics, it works well, and then look on the code if too short or not really robust, and then you have to make again in here. Make sure that we will get in the book the best working code in that ready for production. Okay, you see the difference. This code use Rust high throughput system library. It can read the data. Let me see the main function. Okay. It can read the FASTA file if I'm not mistaken, and more comprehensive code, 700 pages, a line of code, yeah. And you can see here, it compiled the code. When the compile clean from errors and warning, you copy paste again to the book. Okay. So, yep. And next is about differential expression analysis. This analysis is to identify gene that exhibit significant change because of abundance of varying condition. Yeah. So the statistical model, usually using this equation, this is already discussed before. Be careful with this kind of mathematics because it's already discussed in the previous sections. You don't have to put here, right? This is about the dispersion that we discussed before. Okay, and it gives you example of one method called Benjamini Hortberg correction across the test. You can make it more robust again until the code is working. Yeah. And last section is about next flow integration to the expression. It's just, I think this is a very common topic. If too redundant, you can remove this topic. Yeah. Because maybe in other chapter, you can also see. But the last topic is important, this one. Single cell RNA sequence. There is many pipeline in NF core. It is about single cell, DNA and RNA. So single cell technology is quite aggressive recently. There's many improvement in single cell analysis workflow in Nextflow. So in this section, it's introduced this advanced topic for gene expression. So many algorithm here is about clustering. Okay, there is famous method of graph-based method like Lovine algorithm for clustering or Leiden algorithm is discussed here. And then you can implement sample code to show how clustering is actually being used. You can modify this code because this is just a simple count. But if you want to show the clustering based on this text, you just change the code. Yeah. So that's it for chapter 9. Uh, Maybe we should add more uh, image from papers or from uh, let's say from NF Core. Let me check. Is there any gene expression here? No. Expression. Okay. Not specific gene expression. Yeah. But you can find elsewhere. Or the other way to find good example that is you try to ask the AI find in GitHub and evaluate which one is the best and then reproduce in Rust. Yeah. So let's try. Is it already done? Yeah. See, there is a error here. Yeah. if I cargo build 18 errors, right? Okay, just say fix all the 18 errors and warning in this code. It will go one by one and fixing the code. Oops, sorry, not this project, this one. I'll misuse it. Okay. Okay, let's try to find good example of gene expression code in GitHub. I will use this. Okay, find good example of gene expression codes in GitHub. That Mhm. Or more specific, let's say you can put here gene expression analysis. But let's try this one. Okay. So this is R package. This is Python package, SnapPy. Let's try this one. Okay. And you see this code, right? Snappy. Okay. It's quite long code, but it's okay. Let's try. So I will git clone. Let's clone the Snappy. You will see that folder over there, Snappy, Scanpy. Okay. And you can see the project code. And then open your beloved cursor, uh, Snappy. Okay. Okay, you don't need this folder, just delete. Also, you don't need this folder. We just need the folder with source code here. You just delete like this. Okay, I also do. I use that one because we want to port this to Rust, right? Okay, just need this SRC and test. Okay, and I open terminal, cargo new, scan P. Okay. Okay, it's still an empty project, right? And then you can tell the agent, look, analyze the Python implementation of scanp, okay, in root folder src, and test. Then make strategy to port the code to Rust using best scripts. Okay. So I asked the agent, read the Python code implementation, and then propose the Rust structure. Okay. And then he asking you back specific performance requirement or other particulars. And I just say re-implement the scanpy in Rust to improve the performance and concurrency in execution. Okay. And then it will give you the TOML file, create the project, but you need to understand uh, to make sure that you understand the generated code, because it coming from the example of Python, usually it works, but during the compilation, there's many bug fixing you have to do together with the Cursor AI, but not take too long. It takes time, like 1-2 hours, but it can be done. I did it and it works well. Okay, so there's a lot of opportunity. We can improve previous code in Python if you can port it to Rust and improve the performance there, and then share again to community. Like, for example, you can make scanpy RS in the crates. You can share to the community, open source community, because it's coming from open source and you can give him back to the open source. Okay. So that's just the example. But in this book, let's finish the book as a separated, simple code just for students to learn. But in real project, usually you will porting many library, and maybe you can make papers out of there. Better implementation, for example, for ScanPy in Rust. So there's a lot of opportunity if you can do that. Okay. So that's it for today. So please continue on chapter 9. Improve the code because the code is too short, and also improve the background explanation to make it more readable so people can get benefit out of this chapter because the code is reusable at the production level. And also chapter 8, you can also do that again for chapter 8, make the code more robust and comprehensive uh, if you want. But if I see here, it's already 400 pages. I think it's already comprehensive, yeah? Okay, that's it. Is there any question?
So
Yeah.
when we use external grids,
Mhm.
is oftenly lot of error, like chapter 8.2 when we
Mhm.
use GBWT and TileDB. That is external grid. We
Eight.
make yeah 8.2
Yeah. This one, GBWT.
and TileDB. It is two external grid here.
Yeah.
I have installed that, but it's always a lot of error. But when I remove, not using the external grid, it can be work the code. But
That
when you I
Try it.
really try. Yeah, I really try without that crate.
Mhm.
It works. But when I'm using that crate, is cannot be solved. The bug fixing.
Oh, that means this crate is not
Yeah,
mature. Yeah.
yeah, yeah.
So if that is the case, you can find another because this one is actually like a storage, right? Columnar variant. So you can find alternative of this that is better or more mature. But this one also try to find ask the AI which one is better to replace these two. Yeah, you can replace. You don't have to use the
Okay.
immature
I
traits.
already replaced and the works
It
is
works.
run. Yeah.
Okay, good.
Okay. I will change this code. Is be
Okay,
okay. Okay.
yeah. So you guys own the code, yeah? So I will let you do so you can also learn vibe coding, how to make AI code for you, yeah? Start with chapter 9 start with chapter 8. Make the AI works. Looks like this. I can even porting the scan pin, okay? This is the whole the code, okay? And even it asks you, would you like me to implement any additional tools? Okay. And I can say, recommend better improvement and implement them. You can ask the AI, make documentation, make user guide, make a release guide. Okay. You can make it open source. You can write papers out of your improvement, compare with the initial implementation of ScanP. Okay. So a lot of things you can do if you practice this thing. And I hope in near future we can have many activities like this, like improving performance of Python-based bioinformatic codes to us, writing papers out of it for performance comparison and result. Because Python is a scripting language, it's not strongly typed. Rust is very strongly typed. Data structure is very strong. Performance is near to C++, almost the same. Concurrency is better than C++. So a lot of things you can do to make open source project for bioinformatics by modernizing the old Python code like Scanpy. Yeah. And most of the work is bug fixing actually, not writing the codes. But during the bug fixing, you will see interesting journey that AI do the work more than you do. Okay. You're just asking, fix this error. If you find error when you compile, copy paste again and then say, fix this first before this one, and blah, blah, blah. Do it in few hours. Then you can publish in GitHub. Uh, New implementation of this, modern implementation of ScanPy, and other people can get benefit out of it. Okay. Okay, for the book, it's just a simple one main file, but for project like this, usually you already have module. Yeah, module is like component structure in Rust, and yeah, you see, okay. And when you find here, oh, this is a clustering technique. I want to use laden. We cover in the book about laden, right? Or maybe it also it don't have low vein. So you can ask, please implement low vein clustering together with Leiden. Yeah. Only people who understand the mathematics can improve this code because they know that not only Leiden working for this case, but also Lovine graph-based uh, analysis. Yeah. Okay. So any other? Okay, if no question, please continue. Please have fun with the AI and your exploration. Uh, See you again next week. We will cover chapter 10. I think we cannot finish the book this semester, but maybe we can release part one of the book up to chapter 12. Okay? So once we write up to chapter 12, we will fix the reference. We will improve the code to make it more robust and comprehensive for production level. And then we release the book by end of this semester. And I hope use the and you can really get benefit from the book itself. Yes, please. Majeri, you want to talk?
Nothing said. Thank you very much. I'm sorry for coming late. I had a problem with my internet connection.
Oh, it's fine. It's fine.
Yeah.
If you miss something, you can see the recorded video later on. And
Okay.
try to use cursor for your code to help you writing faster code. From example in GitHub, yeah. Uh, you can write in Python, you can write in Rust, but I want the mathematical students to be language independent. You are a mathematician. You are not boxing your skill just Python. If we want to
Okay.
work with, if we have to improve the performance, then let's go with Rust. If you want to have rapid prototype, let's go with Python. Yes, please, Zach. You have a question?
Yeah, I had a question on the pictures that were edging because it's my understanding we're supposed to give a reference of where those pictures are coming from. Are we taking that into account? Because I don't know how to put those references.
I cannot hear you clearly. Your voice is very small.
Okay, sorry about that. I'm not in my room right now.
Okay.
I was asking about the pictures, the references for the pictures. Are we supposed to keep them, then notify you once you update the references?
In the about reference,
Yeah, references for the pictures. Or is it not important to put references for pictures?
I think by the ethics of you have to put the reference in the picture. Yeah. Let's say you take from papers, you can just put the reference of in the caption of the picture. Okay.
Yes, yeah, I did cite inside the text, but then the other the bibliograph, the full bibliograph, that's the one I'm asking about.
Uh-huh.
I don't know how to
Like,
edit in that list.
yeah, like this, right? So this picture may be taken from other place, right? You you can just give the reference. Oh, this is a good picture. Okay, give the reference in the picture.
Okay, thank you.
Good, good, yeah. So we need more picture from papers, from internet. Okay, so yeah, please add more picture in chapter 8, 9. Yeah, some people working in code, some focus on picture, some focus on proofreading. That is the way you learn together. By out of this book, you are capable of doing the code, reproducing pipeline. That is our target. Okay. And also, please start your exploration porting Python code to Rust. I believe you will be very happy to see that it's give many opportunity for you to do more research. Yeah, there's a lot of Python code out there in GitHub that on specific target in bioinformatics, you can port the library. Unfortunately, we cannot put in the book because the code is too long. Like ScanPy that I saw you, it's too long. So book is only cover a small use case of the code. Okay, thank you very much, everyone. So see you again next week on chapter 10.
Makasih, Pak.
Terima
Thank you
kasih.
so